So today topics will cover what are the requirements for the enterprise companies to run workloads in a cloud environment and how you can achieve this with Cloudbreak, which is developed by Hortonworks. So my name is Richard, and my partner will be Peter in this presentation. We are coming from Budapest. So hello from Hungary. So the agenda today will be, what is Cloudbreak exactly? What is this tool doing? And what are the enterprise requirements to run workloads in the cloud? And at the end of the talk, we will talk about how we run Cloudbreak inside Hortonworks. So what is Cloudbreak? So Cloudbreak basically a tool to provision HDP and HDF clusters in the cloud on an automated way, because for sure, if you want to use the cloud environment, you don't want to use only one cluster, but you want to, for example, deploy 10 clusters at the same time. Currently, Cloudbreak supports multiple cloud environments, public and private clouds as well. For example, AWS, Azure, Google, and OpenStack is also supported from the private clouds. We also provide you automated scaling possibilities. So if your cluster is too small for workloads, then you can upscale or downscale based on the usage. Also supports some secured cluster deployments. And the clusters itself highly extensible with custom recipes, or you can use your stamped and IT validated images with custom image feature. So how we ship Cloudbreak? So basically what we provide you now is download Cloudbreak deployer. This is a tool written in Go, and you can deploy a single node Cloudbreak instance itself. It's actually quite easy. The whole tool running in Docker containers, so it's based on microservice approach. So the DB and the API and the web UI itself is running in a separated Docker container. So what is the exact checklist for the enterprises? Let's see. We highlighted some key features, which are control and automation, using real cloud services like RDS, which is provided by Amazon, or VESB, which is on Azure, or ADLS. And also you need some security, for sure. In the control and automation part, I want to describe our simplified UX, powerful CLI feature, and autoscaling. So we introduced the simplified UX some months ago based on the customer feedbacks, and what you see here is the new user experience on Cloudbreak. The main part of every cluster deployment is a credential. So when you want to communicate with your cloud environment, you need a credential. So this picture shows you how to configure a credential. What we provide you is Amazon, Azure, Google, or OpenStack. And on the right side, you see the inline documentation on the UI, where we actually helps you to start the cloud journey and describe you how to set up this whole stuff. We also provide you some built-in blueprints. Blueprints are template files which describe your cluster configuration and services which are running in the cluster. These blueprints are certified and tested by the Hortonworks team, so you can easily grab one of them and start to deploy a cluster with it. We also shipping HDP 2.6 and HDF 3.1 blueprints. We introduced the cluster wizard with the new UX, where you can choose the basic or the advanced option. In the basic option, we're giving you reasonable defaults, and you should only provide the cluster name and the password for the cluster. But in the advanced scenario, if you want more security, for example, or you want to actually configure an RDS on your cluster, then you can do it as well. So the network and the security part. So basically, that's always a hard decision for an enterprise. How can I configure my network? If you have an existing network already in your cloud provider, then we're giving you an option to choose that network and use it in a cluster deployment. We also support to use existing security groups on your cluster. And how it works, basically, we're using your credential, going to the cloud provider, querying your domain, and that's it. You can use it. So the CLI. Basically, we want to give you a tool which is usable for cluster deployments, and this is why we introduced the CLI part of Cloudbreak. You can download it from the UI, as you see, under the download CLI option. And we provide you Linux, OS X, or Windows binary. It's written in Go, and if you are familiar with cloud CLIs, then probably that's not a problem to use it. But if it's a problem to use it, then we also provide you an option to check what is the exact CLI request which we are sending from the UI. So it's kind of a hint for you. Regarding the autoscaling possibility in Cloudbreak, the three main building blocks is the alerts, which are Ambari alerts and Prometheus alerts. Ambari currently supports 400 metrics, so you can easily use that. When an alert's triggering, then a policy defines the behavior for the alert. So you can basically say that my name node space is too low, and I want to add 2 new nodes to my cluster. The general configuration is mostly for define the minimum and the maximum cluster size. So how it looks like. So when you define a time-based alert, then you have to define a time zone for the alert and a cron expression, where I want to trigger that alert. If you choose the metric-based, then you have to choose one of the Ambari metrics and then define what is the status of that one. So when you define a policy, you have to choose an alert, as you see, in the right side, a host group, and actually the behavior what will happen when an alert is triggering. So adding node or removing node from the cluster is quite easy to use. Peter?
Thanks, Richard. So I will dig into some of the highlighted features which are supported by this Cloudbreak tool. So first of all, what's this cloud services all about? So it's twofold. We are referring for both the services in the native services in the cloud, like Richard already mentioned, the RDS, so the relation and database service or the object storage. We want to utilize that features. But besides that, we want to use our products in a cloud-friendly way. Like, for example, we want to be able to use the Hortonworks DataFlow in the cloud as well. So I will talk about these topics next. So what about the cloudy resources? So oftentimes it happens with the paradigm shifting towards the cloud, that the clusters are not long running anymore. They are more of an ephemeral status. So you just submit your workload, wait for the workload to finish, and after that you stop your cluster. And that's why the cloud resource is coming to the picture, because you can have the RDBMS running and provided by the cloud provider itself, and you can have an LDAP provided by the cloud provider itself. So how we support these scenarios? So all of these configuration parameters used to be in the blueprint. So those has to be set inside the blueprint, which was a pain point, because if you had the chance to connect to an LDAP, it can be up to, I don't know, 10 or 12 configuration parameters on each cluster launch. And we provide this feature called dynamic blueprints, which lets you define these LDAP and RDBMS as external sources and reuse those sources and inject those configurations automatically into the blueprint, which Ambari processes later. So how it works, as you can see, to configure an LDAP connection, it takes, I don't know, that many parameters, so it's a pain to do that every time when you are launching a cluster. So you only have to do that once with Cloudbreak and reuse that. And that's the good part. And how it works, it automatically parses the blueprint, whether it contains JDBC or LDAP-related parameters in it. And we obviously don't want to be smarter than the end user. So if the end user has already specified his configuration parameters, then we don't want to override those. But if not, then we will inject the parameters based on the previously defined resource. So this is to ease the usage of these kinds of components. Yep, so here's a little main. Okay, so what about HDF? So customers has constantly asked and pinged us about when will we finally support Hortonworks DataFlow. So now we support it. And there is a default blueprint, a built-in blueprint called Flow Management Apache NiFi. It contains HDF 3.1 with components NiFi, Ambari, Matrix, and Zookeeper inside it. So our goal was to be able to launch HDF as simple as you can. So it's very, very similar to launching an HDP cluster. The only difference is that the platform is HDF. So afterwards, you can configure everything, every single aspect, just like in launching an HDP cluster. What about these custom images? So why do you need an image? So in cloud, every VM starts from an image. So that's how it works. And by default, so Cloudbreak launches the clusters and the clusters VMs with a base image, a default base image. And afterwards, Cloudbreak installs Ambari to those images, and Ambari instructs the Ambari installs the HDP related bits afterwards. So that's how it is working by default. But okay, so by default, that's how it is working, and we are providing these standard operating system images for all the cloud providers. So we are going with Amazon Linux in AWS and CentOS for all the other providers. And yeah, this is a reasonable choice for, I don't know, the half of our customers. But what if it's not? What if they are going? They do want to go with RHEL, or they want to go with Debian, or I don't know. So that's how custom images come into the picture to solve this issue. It's a 3-step process. So you have to create your custom image, you have to register your custom image to be able to use in Cloudbreak, and afterwards you can launch your cluster with that exact custom image. Creating an image is based on a Cloudbreak images GitHub repository. It's a publicly available repo. You can have a look at it. There is documentation for it, and it uses Packer, which creates the VM infrastructure, and it launches a salt provisioner, which places all our softwares and the required softwares and all the settings which are required by the HDP cluster afterwards. So if you would like to try it out, you can look at it right now. And what are the custom use cases to use these custom images features? So first of all, for example, you don't want to use AWS, Amazon Linux for AWS, you want to go with RHEL. And it is as easy as setting some environment variables and calling a make target. Or your corporate policy implies that you cannot use OpenJDK, but you should use Oracle JDK instead. Then we have a salt state. You only have to turn that state on. It's a environment variable, setting an environment variable, and building a custom image. Or the most common scenario that we have seen is that the customer wants to use his own image, certified by their internal IT, and so they want to use that image. And that is possible as well, because you can change the base image, on which the whole process is started. And afterwards, the image is burnt. There is a image catalog which maps the images to the Cloudbreak versions, and you can see it on the top of the slide. When launching a cluster, all you have to do is choose an image catalog, choose an image from that image catalog. As you can see, it's an Amazon Linux one for now. And inside the image catalog, there are default values for the default and tested HDP and Ambari, which we recommend you to use. But you can choose to override the default value if you'd like to. There is a concept of pre-warmed images, which means that the Ambari and HDP bits are already downloaded and installed to it. So there is the pro exactly. So the cluster installs will be faster, way faster if you go that way. But you cannot change Ambari and HDP versions because they are already pre-burned to that image. But you can choose that as well. Okay, so what about security? So most probably you have already heard about Kerberos. It's the de facto standard for authenticating inside the distributed system. And the good news is that all the feature set that Ambari provides, which is a very rich feature set, is exposed through Cloudbreak as well. So that was the goal, to be able to use Kerberos and configure Kerberos as easy as you can. But if you'd like to, you can leverage the full configuration possibilities inside Cloudbreak. On the cluster install wizard on the UI, and this is the checkbox. So this is only a checkbox, but afterwards you have many possibilities. So the recommended way and the enterprise standard way is to use your own existing KDC, which is the key distribution component for Kerberos, which is the so-called master component for Kerberos. So this is our recommendation, to use your existing, because in your company, if you are installing a Hadoop cluster, most probably you will have your own KDC and Kerberos set already. And we have this option to use the test KDC, which means that we are installing into the cluster a KDC, which is pre-configured by us. So you only have to set the username and the password, and all the rest is configured by the Cloudbreak. So this is not meant for production, but this is good for some POCs. And you have the option to inject the configuration properties in an advanced view, which means that you can export from the Ambari the Kerberos config, and you can inject it as it is, as a JSON file. So it is available as well. So I've already talked about integrating the RDS, integrating into the RDS and the cluster to the LDAP. But what about the Cloudbreak integration to the LDAP and AD? Because that question comes up quite often from the enterprises, that I've got users, I've got groups, and I have to integrate those corporate users and groups to my Cloudbreak application. Is it achievable? And the answer is yes. So it can be done with two simple steps. Number one is that you have to set up in our parameter file the connection parameters to your corporate LDAP. And after it is set, then we have a utility called CBD, and by executing these two commands, an LDAP group will be mapped into Cloudbreak group. So you can say that I want to give and authorize analysts group to access Cloudbreak, and you can do that by executing that cbd util command in the last paragraph. Okay, how we are with time? Okay, so getting to the proxy configuration. This is a very typical enterprise setup as well, when they have the cluster or Cloudbreak or both don't have direct internet connection. So so a proxy is in between. So we do provide support for both the Cloudbreak usage with proxy or the cluster usage with proxy. This is the problem. So how does Cloudbreak communicate through a proxy, or how do the cluster host communicate through the proxy? So this is the Cloudbreak scenario. As you can see on the left part, Cloudbreak communicates with the cloud providers, and it can be done via a proxy. It can be configured by setting some configuration parameters in the profile. And if Cloudbreak communicates to the cluster via a proxy, it is possible as well. So both these proxy setups are supported. And what about the cluster? So for the cluster, you can create a proxy configuration as an external resource. So you have to create this proxy setting just once, and you can reuse it for every cluster that you create afterwards. So this works quite like the database configuration and the LDAP AD configuration that I was talking before. And what it does, it configures the package manager and Ambari server to use that proxy. And let me hand it over back to Rihad. He will talk about our internal effort.
So in Hortonworks, hello. Oh. So in Hortonworks, we already certifying HDP and HDF on the cloud platforms. So how we can achieve that? It's a very hard choice. No, it's actually not. We have Cloudbreak, so we can use that for provisioning HDP and HDF clusters in the cloud. So we actually deploy the Cloudbreak inside Hortonworks to help to the QE team, the PS team, and the SE team to deploying Hadoop clusters in the cloud. And we also using that environment for stress testing, penetration testing. So what were the technical goals for this? Because if you provide an option to a lot of people to provision clusters, then for sure you had to provide an AJ setup for your environment. So the technical goals was to upscale the Cloudbreak component itself. Because if we get a much higher load on the service, then we have to actually scale up the components. And we chose Kubernetes to run Cloudbreak inside Hortonworks. So inside Hortonworks, we're running a Kubernetes cluster. We're running the Cloudbreak itself. And why Kubernetes, actually? So it's quite a buzzword today. So we actually investigated the Swarm, Mesos, and Rancher, and we bet on Kubernetes because of the tooling, because of the provided solutions what Kubernetes give us. For example, Kubernetes has a quite good integration with the providers, like with GCP, AWS, or Azure, or you can use S3 or GCP bucket under Kubernetes. So thank you for your time, and if you have any questions, we are happy to answer it. Hey. Oh, sorry, I didn't hear it, actually. Do we have a microphone? Oh, sorry. So?
Yeah. So you mentioned that we can provide the custom images for the Cloudbreak. Yes. To have our own images. So what kind of images are we talking? It is some custom imaging solution for Cloudbreak, or is it cloud provider specific images, or is it Docker images we are talking about?
Yeah. So the answer is in the middle. So yeah, they are the cloud provided images. All the cloud providers have their own mechanism to provide images, like AMIs in the AWS world or VHDs in the Azure world. So we are making. Okay. We are talking about those.
So if I want to provision across clouds, I need to have their specific images created before using this.
Correct. Yes. Okay.
Any other question? Yes.
Yeah, so one question is Cloudbreak also supporting temporary instances in the cloud?
Temporary instances means?
So like what's it called in Amazon, ephemeral, or Google Cloud?
Spot instances, you mean? Yes, we already support spot instances. What you have to configure is basically the price of the spot instance, because as you know how spot instance works, if the price is higher than your defined price, then AWS automatically terminates your instances. So the answer is yes, we support.
Is it also handling then the rebalancing of the HDFS and so on, because instances are pulled out?
Yes, so we actually recommend to use spot instances and preemptible instances for the compute nodes, because you have to actually provide something to the user to know when my spot instance will be terminated, but it's a magic on AWS side. Other questions? Then thank you.
Thank you.